Now, this section we are looking at identifying your bad data points. Most of the time you need to be the first part of interpreting your data after you might have acquired your data with a GD10 or GD20. You need to see your data you've acquired in the field just by after you might have downloaded. You take this process 6, you can read your data. Now I want to show you some of the data gathered within GD10, and you will see some bad data, also see some good data. I will show you this data. Let's look at this data in line 5. You see, you bring it in using this is Res 2D inversion application. You can also use Res 3D inversion depending on actually what you are working on. So this is reading of data file completed. It means that in this data we run our profile north south directions, and the spacing is 5 meters. We use dipole arrays, and the total number of datum here is about 771. This is just the IP values given in terms of meter per seconds, and the minimum electrode starts at 0.0, and minimum electrode spacing is 5. Data levels layouts is just about 33, and total number of electrode we use there is 48. First electrode is located from origin 0.0 and ended at 235. So the total length of this survey is 235 meters. Total valid IP point is 770 out of 771. So if you say OK, now you see this message warning, minimum and maximum apparent resistivity values are this and this. Now, what is it trying to show you here? It means that the maximum apparent resistivity value is more than 300 times the minimum value. So this is just a signal that you have a wide variation between the smallest and the highest. So you need to be careful. So as a precautionary measure, some options that include direct smoothing of model resistivity values will actually be enabled to help you remove some of the noisy data or bad data point. But however, you can still want to disable DIGs. You can go to some appropriate options under the inversion and change settings in DIGs applications to do that. But what actually we are trying to look at is we want to see the bad data point. So what do we do here? Just we'll go to edit and see exterminate bad data points. Now it will bring you to another window, which is edit data window. This edit data window will show you your lines according to layers. You can see we have 5 up to 35 here. Now, when looking at this without even zooming here, you can zoom up and you can zoom down. You can observe that there are some kind of noisy data here in this resistivity values, and you can display both. You can choose whether to display your resistivity values or display your IP values. Now, this is resistivity values. If you look at this, you can see that this point here crosses up to the next layer at this level. If you look at this also, now look at this also. Apart from this, you can zoom in. You see, as you zoom in, they appear very well. You can zoom down. You can also zoom down. You see, nothing appears. So the maximum zoom up here. So what do you do? By clicking on this, you see, you can click on this. These are bad data points. You're identifying the bad data points. So when you click it, what happens is it marks it red. You click it, it marks it red. If you want to deselect it, you can double click. You can click it again. By clicking, it marks it. So it means this you identify here just by main observation here that this actually bad data point. So you need to be careful. You can look at this point again. This is on this kind of survey. Now let's look at choose the IP. Let's see the IP data. Now what you've chosen there, you can see that the IP, look at the IP data, looking at the IP, looks very neat. The IP data here is, this is obviously very bad data point, and you can see just isolated. So this is how you can identify by data points. You can select this, you see, select it. When you select this, it goes out. Now you can, let's zoom down. Then when you zoom down, it seems as if nothing is happening. You zoom up, it comes out a bit clearer. So that is how you can identify this. Now, if you exit this window, he said you want to exit, say yes, exit, it has been updated, then you can save this. Always understand, you save this as edited. Always try to save the edited form in a different format. Like you can see this already added edit, means that this is a edited one. This is the original data that is actually tampered with, so that in case you have any issues, you can still go back to your original data. If you save this, it saves, it will replace the old one you save. You actually save this. So that is how you can identify them. Then let's look at another profile and see some differences. If you want to read another profile, let's look at this profile prospect 2. What do we choose? Let's choose this. Let's pick another profile from this. Now this is a different one. The spacing here is 5. Also the same number, 771. This one 771 datum point, and valid IP data point is also 771. The same electrode numbers, 48 electrodes, and the electrode located at the first electrode is at 0.0, the last electrode is at 235. So it has finished reading this data. Now there's a difference between this data and the last data. You can see in this data there is no signal message for wide variation in resistivity values. So possibly this data is not noisy compared to the first profile we showed up. So because if it was noisy data, you will see a lot of variation. So what it does this actually showing here is just that it's trying to tell us that there are some data at the suffix that appears to be larger in terms of resistive variation near the suffix. So this kind of data, you can actually obtain a better result if you want to model them by using a cell width that is half of the unit electrode spacing. So you can actually solve these issues. But if you look at this data, the first signal that was shown in the other one wasn't actually shown here. So what do I mean? Let's see this data. Exterminate bad data points. Let's go to edit window. You can see it's obviously cleaner than the first one. Now, even if you zoom in, let's zoom up. If you keep zooming up, you see the data looks very good, just except somewhere here, maybe at this point. But if you look at the data generally, it looks better than the last one, so the variation is not much. Zoom down and all that. Then let's look at its IP. Now let's display the IP data. The IP data is very clean. You can see, just accept this. You can see this. Let's zoom down and see this is obviously out of the way. So this can actually be taken, So now there's another thing you need to do here. If you are rescaling, you can choose whether you want to rescale profile displays, or you just want to do it, let it be done automatically. After each time you eliminate or restore any data point, you can choose to change vertical scale using drawing your profiles automatically or just manually, because this helps in case with some few data points with very large error. So, and after removing the worst data point, the other bad data point might show up if the profiles are rescaled automatically. So this is, you can look at this rescaling options to do that. Then if you are through with this, what do? You can also display your, so we've chosen about just 2 data or 3 data points within the profile. You can exit and save. you quit the window, want to return the changes you made, you say yes, it will be updated automatically, and you save with another name. You can save this and that, edited. So always try to save it differently from the original so that you wouldn't have actually modified the original data. So with that option, you've actually finished observing bad data. There's another way you can actually look at your bad data, because this is just by mere observation using the DIT window. Another one is you can also do that by going straight to the, to the window where you saved your data and open it in another, like if that file you can open in using another window application, or you can open in Excel, because when you withdraw your data from GD Studio, it can give you 3 different kind of data, either in that file or in Excel or CSV. So you can also do that individually. Then that is by saying, going to where you save your data, you can, but this will actually take you so much time, in checking it out. Let's assume this is the data we open up before. You can see it gives you data in text file. This is the text file. This is where you see your data in text file. Your voltage, your geometric factors, your current, your resistivity, your SP, your chargeabilities, average chargeabilities, and all that. This is the text format. Then the data can also be exported in Excel format, which is this. You can see data here. You can see your resistivity values. Look at your resistivity values here. You can see your resistivity values. You can identify through here. You can, if you do a kind of a plot here also, you might try to see where you have a very large data. You can use Excel, use the line, maybe if you want to identify large data from here. You see, very large data. Very large data. You can see, just looking at, trying to see, oh wow, you can see where you have, then this is very slow. Why becoming slow? You can see where you have noisy data, very large anomaly, very large data here. You can see, and see. So you actually need to see that this is very obviously higher than what you have here. So though if you look at this, they can actually be a kind of a different information here too. You can see this, the variation here is not much, but variation here is much. So you can actually run quickly to this point and see what's actually happening there. So that is it. Then you can also look at your data in that format, opening using Notepad. That is your data. You can view your data in this format also and identify some numbers that you think wrong. But I think the easiest one is you can use a DIT window to observe the data first of all before you go into some other kinds of setting using resistivity R2. This is your inversion parameter setting, which you can now go into your modeling and other aspect of it. For now, this is just the way you can observe your data.